Hey, hi everyone. Right now, you are actually looking at a retest paper. A retest paper I have set for one of my students. So let's look at the first questions. Okay. So the first question here is, it says given that 2x is smaller than 17, then state the largest possible value if x is a prime number. So first thing first. So I need to let me. So the question says, if x is a prime number, that's part A, and then part B is x is a multiple of 3. So let me explain to you what is a prime number. Okay. So what is a prime number? So the definition of a prime number might vary from person to person, but my understanding of a prime number is divisible by 1 and itself. Okay, or you can actually take this definition. So prime number has factors of 1 and itself. Okay, they should mean the same thing. Okay, let me give you some examples of a prime number. Okay, so prime number. Okay, the first prime number is actually 2, and then 3 and 4. Okay, 4. By the way, let's see if 4 is a prime number. So to find that if 4 is a prime number, first we need to find out the factors of the factors of 4. So to find the factors of 4, I like to start with 1 first. So 4 is equal to 1 times 4, and then I start with 2 next. So 2 times 2 is 4 as well. So last but not least, 4 times 1 equals to 4. So therefore, by doing this, you can actually find that 4 has factors, or rather 4 has these factors. So they are 1, 2, and 4, right? And therefore 4 is not a prime number, because what? Because the definition of prime number is prime number has factors 1 and itself. So over here, 1 is here, itself is here for 4, but it has these 2. Okay, so therefore 4 is not a prime number. 4 is not a prime number. Okay, so let's move on. So 5, yeah, 5 it is. And then what? So as you can see, 1 times 2, right? So over here is what? 1 times 3, and then over here you have 1 times 5, and subsequently you have 7. Okay, and dot dot dot. Okay, so in order to find prime numbers, remember the definition here. Okay, then we look at the question. So it says what? It says x must be a prime number, and it must also fit this requirement. So for this, you have 2x smaller than 17. Okay, if you have learned how to do inequality, what you do is you just need to divide by 2 on both sides. And what do you get? You get x smaller than 8.5, right? So that means the value of x must be smaller than 8.5. So from 8.5, and then you go leftward, that means less than 8.5. And the largest possible value of x, if x is prime number, so let's start from the first prime number, 2, 3, 5, 7. So among these 4, which is smaller than 8.5 and the largest? So clearly the largest is 7, right? And then it is also smaller than 8.5, right? So therefore 7 is the answer. Okay. Okay, can you choose the next prime number, which is 11? Okay, can you choose 11? Is 11 okay? The answer is no. The reason is 11 is not smaller than 8.5. No. Okay, so therefore 11 is not okay. Okay, next. Okay, let's do the second part, which is you need to find x such that x is a multiple of 3. So what I do is I need to start to write down the multiple of 3. So the first one is 3, and then the next one is 6, and then 9, and subsequently, right? So the reason is this is 1 times 3, or rather 3 times 1, and then this is 3 times 2, okay, and then this is 3 times 3, and then so on and so forth. But the question clearly says what? The question clearly says it must be smaller than 8.5, and it has to be largest. So 9 is out. 9 shouldn't be there because 9 is bigger than 8.5, so it doesn't fit the requirement here, right? So therefore I choose 6. Okay, so that's how you solve this question. By the way, this is a 1 mark. This is a 1 mark question. So working is not needed, strictly speaking. If you want to show your working, fine with me. If you don't want to show your working, I'm also fine with it. But it's always a good practice to write down the working. Okay, next question. Given that k is equal to this, so by the way, let me write it again. K is equal to 2 to the power of 6 and 7 to the times 7 to the power of 2. So over here it says positive square root of k. So what you do is you just need to give it a square root. And then how you do square root is you can either punch the calculator or you can do it this way. Okay, so you can actually split it. Okay, you can just split it. So this is the first term, this is the second term, and then they are combined with the times. So that's why I split it into these two. Okay, next, what do you get? So you square root this, you get 2 to the power of 3, and then this you get 7. So therefore the answer is 2 to the power of 3 is 8. So 8 times 7 is 56. So the answer should be 56. Okay, for part 1, part A. Yeah. For cube root of 7k, right? So what do? You do this. Okay, so you just 7 times the k is this. Okay, and then what do you get? You get 2 to the power of 6, and then 7 to the power of 3. And then after that, you just give it a cube root. So similarly, you split them. Okay, and then the first answer you get here is what? The first answer you get is 2 to the power of 2, and then you get the 7. So 4 times 7 is 28, right? So the answer is 28. Okay, pretty easy, pretty fast. Next, let's go to the next question. Okay, over here it says with the use of a calculator. So what you should do, you just punch this whole thing into a calculator. But over here I want to emphasize how do you find 4 significant figures for anything. Okay, so let's talk about the concept of significant figures. Okay, so for significant figures, let me give you a few. Let me give you some questions, and let's talk about significant figures from here. Okay, so let's take a look at the first number. Okay, the first number is actually 0.00234556. Okay, to find significant figures, the first valid significant figure should be a non-zero figure, and then you start from there. Okay, so remember, the first valid significant figure should be a non-zero figure. So let's look at this. So is this a non-zero? Okay, this is a 0, right? So I shouldn't start here. Okay, and then after the decimal point, is this a 0? Yes, it's a 0, so I shouldn't start from here. I should start from a non-zero. So if you look at it, I should start from here. So 2 is the first significant figure, and then 3 is the second, and then this 4 is the third, and then this is the fourth. Okay, to find, let's say I want to find the 4 significant figures. So basically I want to express this into 4 significant figures. I should look at the 5th. Okay, I should look at the 5th one. Okay, and the rule is always, if the 5th, because I want to I want to express this into 4 significant figures, right? So I need to look at the 5th figure. Okay, if it's more than 4, I need to add 1. So I need to add 1 to the 4th. I need to add 1 to the 4th figure. Okay, if it's less than 4 or equal to 4, I do not add. Okay, so remember this. So in this case, what? In this case, 6 what? 6 is more than 4, right? So I need to add 1 to this. Okay, I need to add 1 to it. So therefore the answer for this is what? The answer for this is, so it's 0.002346. So I need to write down 4 significant figure, short form. Okay, good. So let's look at the part B. So let me erase this. So I have more space. So for part B, 1.00234. So the first significant figure should be a non-zero figure. So this is the first, right? Because it's non-zero. So therefore this is second, and then this is third, and then this is fourth. So I look at this 3. Okay. So since 3 is smaller or equal to 4, so no need to add, right? Okay. So I do not add. Okay. So if you don't add, so you end up with 1.002 for significant figure. Okay. Yep. So back to the question. Okay. So for this question, I'm not going to do it because I've already explained how to find 4 significant figures. Okay, but let's look at this 9/11 as recurring decimal. So 9/11, what you do, just punch your calculator. So I have my calculator here. Let me look at my calculator. 9/11, and then I get what? I get 0.818181 and dot, right? Okay, and I have to express it in this manner. Okay, because the 81 is repeated, so that's the reason why I need to put the 2 dots on top to show the 2 dots on top, which is here, the 2 dots on top highlighted in yellow, to tell that, okay, 8 and 1, they repeat. Okay, they repeat after that. Okay, so pretty simple. Next, let's move on. Okay, over here it says what? It over says write down the integers. So by the way, over here you cannot see clearly. You have a 1, and then you have pi over 11, and you have a square 43, and then you have this, and then you have 31. Okay, for integer, so what is the definition of an integer? So for integers, you have the negative integer, and then you have 0, and then you also have plus, which is positive integers. So some of the examples is -1, -2, so these are negative integers. And of course you have 0, and then for positive you have 1, you have 11, you have 37. Okay, so to find integers, so clearly here 1 and 31, they are integers, right? Am I right? Okay, so next, prime numbers. Okay, prime numbers. So once again, let's go back to the definition of prime numbers. So prime number, or rather prime numbers have what? Prime numbers have factors of 1 and itself. So therefore prime number have factors of 1 and itself. So over here, remember the first prime number is start from 2 and 3 and blah blah blah. That's prime numbers, right? So I just want to caution people here, students here, 1 is not a prime numbers. Okay, 1 is not a prime number. Okay, so for prime number, clearly in this case 31 is the one, right? Okay, 31 is the one. Okay, so now irrational numbers. So I just did a Google search. So to find irrational number, so I just want to copy the definition here. So for irrational number, so let's create one more slide. So for irrational number so over here it says an irrational number is a real number that cannot be written as a simple fraction. So irrational means not rational. So cannot be written as a simple fraction. So let's look back at this. So cannot be, remember that? So cannot be expressed as a simple fraction. Okay, cannot be expressed as a simple fraction. So therefore it's a simple fraction. So what is a simple fraction? Okay, what's a simple fraction? Okay, so simple fraction, so let's click into this. Okay, by the way, you have to memorize this. Okay, so clearly the first example here, it already tells you 1.5 equals to 3 over 2, so this is rational. And then pi is equal to what? Pi is equal to 3.14159, so it's irrational. So that means pi is not really. So let me get this out. So let me get it here. Okay, so clearly you can see that pi is irrational. So therefore, in this case, if you want to find irrational number, so clearly here, this one, pi over 11, yeah. So pi is irrational. So therefore, what? Pi over 11 also is not rational. Okay, so therefore, pi over 11 is here. Okay, and then what about, so square root 43 is also irrational. Okay, then what about this negative 49? Actually, you can actually simplify it. You get negative 7, right? So negative 7 is what? Negative 7 is a integer, right? It's a negative integer. Okay, it's a negative integer. So therefore, I should write my answer here. Negative 49, right? Okay, so that's how you do this question. Okay, let's move on. Over here it says express this to four scientific figures. So yep, I have already explained that. So therefore what you get is once again the first valid scientific figure is start from a non-zero figure. So this is a 0, this is all 0, so that means this is my first, and then what, this is second, and this is third, and then this is fourth, so I look at the fifth. So 9 is bigger than 4, so I need to add 1 to it. I need to add 1 to it. Yeah, I need to add 1 to this. So you end up with what? So 0.01019, you add 1 to it, you end up with what? 0.01020. Okay? To maintain 4 significant figures. So 4 significant figure. Okay? Next, 36 seconds as a percentage of 5 hours. Okay? So they want you to convert 36 seconds as a percentage of 5 hours. So let me talk about this question on a new slide, because so 36 seconds. as a percentage of 5 hours. So the first thing you do is you convert the hours into minutes first, and then convert to seconds. So the conversion is 60 to minutes, another 60 to seconds. So what you do, just 60 again. Okay, so you get 300 and then 60. So you can actually use your calculator if you're not good with a mental calculation. So 36 seconds. So 36 seconds over this 18000. So what do? You divide by you divide by 9 first. Then you get 4. You divide by 9. You get 2000, right? And then you get divide by 4. You get 1. You divide by 4. You get 500. So this is the fraction, right? Okay. And then of course just times 100%. Then all you need to do is what? All you need to do is just punch the calculator. So to find percentage is times 100%, and then copy the percentage down, the percentage sign down first, and do the calculation in front. So what you do is this 1 over 500 times 100. Okay, you get 0.2%. Okay, so that's the answer for part 2. Okay, 0.2%. Next, this percent as a fraction in simplest form. 1.05% to fraction. Okay, let me get it to a new slide. So you get 1.05% to fraction. Okay, very simple thing. What you do is, so in order to get rid of the percentage sign, what you do is you move the decimal point to the left by 2 decimal points. Okay, so just fill it up with 0, and then your decimal move it to the left by 2 decimal places. So you end up with 0.0105. Okay, so they ask you to convert into fraction, right? So this is a decimal, and then just do this. Okay, so you convert to fraction, and then all you do is you divide by 5, you get 21, you divide by 5, and you get this, right? So the answer is this. Okay, very easy. Okay, next. Okay, over here, arrange the following numbers in descending order. Descending order means what? It means biggest first and then subsequently. Okay, that means, so to arrange numbers, the best practice is you arrange it in a vertical order, okay, so that you can compare them one by one. So first I start with this. Okay, the start on top, what it means is you just repeat the 9 all the way. Okay, next 0.909. So what this means is this 3 will repeat itself. So it will repeat itself. Okay, most likely I want to like give more 9 so that you have a better comparison. Okay, next 99%. So 99% what? 0.99. Okay, next, so 10 over 11. So for 10 over 11, I will suggest you to 0.909. Okay, so it works like this. So it's 0.9090. So basically the 90 repeat by itself. Okay, or in this case you just have to write it properly. So you can fill it out with 0 on top here. So 90. Okay, that's it. So if this is good to go. Okay, so you compare the first figure first. Okay, so over here all 0. Here you compare the 9, all 9s. Okay, next one you compare this. Okay, you can clearly see what you have a 9 here and then you have a 9 here, right? So you need to compare these two. To compare these two, what you do, you compare this. So for 9 and 0, so which one is bigger? Clearly 9 is bigger than 0, right? So therefore the biggest is 0.9 dot on top. Anyone else? Okay. Next is 99%. Oh, by the way, you need to write. You don't need to write this. You need to write the number that's given. Okay. You cannot write. You cannot write. You cannot write the You cannot write the expansion. Okay. You need to write the number that is given to you. That's why you write 0.9 dot on top, and then 99%. And of course, now you need to compare these two. Okay, the green color. You need to compare these two to see which one is bigger. So focus 9 and 9. Okay, good. Same. 0 and 0. Same. 9 and 9. Same. 9 and 0. So which one is bigger? Definitely this is bigger, right? So therefore, you need to write down 0.909. So this is bigger than the smallest is actually 10 over 11. Okay, so this is the answer. Okay, or the way you do it is, or the way to express is this is, you can actually do it this way. Okay, so you put a inequality sign. Okay, next. Okay, this question. Okay, so you have 180 chicken wings, and then you have 240 sandwiches, and then you have 300 fish ball for a party. And assuming each guest eats the same quantity of each type of food, what is the largest number of guests he can invite? Okay, so this is the concept of what HCF and LCM. Okay, I would like to use a page to teach the concept of HCF and LCM. Okay, so HCF means highest common factor, and then for LCM is lowest common multiple. Okay, so for HCF, right, so let's come back to this question. I still remember let me see, so you have 180 and 240 and 300. Okay, before I do that, let me give you some examples. So let's say the example is 40 and 50. Okay, so my way of doing this is, my way to do this is, let's talk about how to find the HCF, highest common factor. Okay, my way of doing it is, I will do the prime factorization of 40 first. So I start with 2, I got 20, and then I have 2 again, so I have 10, and I have what? I have 2 again, I have 5 left. Okay, so I will stop at this. So 40 is actually what? 2 to the power of 3 times 5. Okay, now I will do for 50. So I start with 2, 25, 5, 5. Okay, so 50 is equal to 2 times 5 square. Okay, very simple. Okay, so how to find the HCF? Okay, so my way of doing it is, I want to remember to find the HCF between these two numbers is shared terms, or rather shared numbers, and choose the lowest power. Choose the lowest power. For the shared term, shared numbers. Okay, so therefore in this case, HCF of 40 and 50. So let me look at it. So is 2 shared between these two numbers? Is 2 shared? Yes, 2 is shared, right? They both have 2, right? So 2 is there. So do they share 5? Let's check. Yes, they both shared 5. And then I should choose the lowest power, right, for the shared term. So the lowest power, so you have 3 here and you have 1 here, right? So when 1 is not returned, so it means 1. So I choose the lowest power, so I choose 1. And then for 5 and 5, oh, by the way, let me write this properly. Okay, so between 1 and 2, I choose 1. So the answer is 2 times 5, which is 10. So the HCF for 40 and 50 is 10. Okay, next let me continue with LCM. Okay, so for LCM, okay, let me erase this so that I can have more space. So let me erase. Okay, for LCM is also very simple. Okay, terms. Oh no, let me not use terms. Let me use numbers that are present, and then highest power. Choose the highest power for the numbers that are present. Okay, so in this case you can see, right, you only have 2 and 5, right? So immediately, so for LCM of 40 and 50, you have 2 and 5. Okay, no question about that. And then choose the highest power. So what's the highest power between these two? So you choose 3, right? Because 3 is higher than 1. So between this 1 and 5, you choose what? You choose 2, because you need to choose the highest power for LCM. So therefore 2 to the power 3 is what? 8, right? So and then this is 25, and the answer is 200. Okay, so that's the LCM for 40 and 50. So let me come back to this question. So what do? You do the prime factorization of this first. Okay, so 2, 5. So 180 is what? 2 to the power of, how many 2 you have? You have 2, 2, right? And then you have 3, you have 2, 3, and you have 1, 5. So similarly, you do it for this. So, oh, let me double check. Okay, good, 15. And then you have a 3, and then you have a 5. So 240 is, how many 2 you have? 1, 2, 3, 4. You have 4 of them. Okay, next. You do it for this. Okay, so 300. Okay, let me put it at the bottom. So you have 300 equals to, how many 2 you have? 2 to the power of 2, right? Then you have 2 5s. Then last but not least. Okay, so let's go ahead and find out what is the HCF. HCF is, if you remember, okay, HCF is what? Shared numbers and lowest power for the shared numbers. So shared numbers and lowest power. So shared number and lowest power. So let me see, what numbers are shared between these? So is 2 shared? 2, okay, 2 is shared. So is 3 also shared? Yes. So is 5 also shared? Yes. All of them have these 3, right? So what do you? So you have 2, 3, 5. So for HCF, I need to choose the lowest power. So what is the lowest power? 2, 4, 2. So I need to choose 2. Right? Okay, good. Next, for the 3, the lowest power is, so over here is 2, over here is 1, and over here is 1, so I choose 1. So for the 5, here's 1, here's 1, and then here's 2, so I choose 1. Okay, so clearly this is what? 4 times 15. So the HCF is 60. Okay, so for the LCM, so as long as it's present, then you choose the highest power, right? You can actually refer to it. So numbers that are present, and then the highest power for these numbers that are present. So what you do is you choose the numbers that are present. So you have 2, 3, 5. then you choose the highest power. So for 2, the highest power is 2, 4, 2, so I choose 4. So the highest power for 3 is 2, 1, 1, so I choose 2. Then for the highest power for 5 is 1, 1, 2, so I choose 2. So what you end up with is 2 to the power of 4 is 16, and then 3 to the power of 2 is 9, and then 5 to the power of 2 is 25. Okay, so let me punch my calculator. So I have 16 times 9 times 16 times 9 times 25. So I get 3600. Okay, so over here, if you look at it, what is the largest number of guests he can invite? Okay, so you should choose what? You should choose HCF 60, right? The reason is, if you choose the LCM, which is 36,000, so 36,000 guests is way smaller than the 180 chicken wings and 240 sandwiches and 300 fish balls that you can feed this 3600. So it doesn't make sense for you to choose LCM unless you want them to eat a fraction of wings, a fraction of sandwiches, and a fraction of fish balls. And I don't think they want you to do that. Okay, so the answer is you need to choose the HCF here, which is 60. And then with 60, how many sandwiches? So sandwiches is 240, so you just take 240 divided by 60. So actually you end up with 4. So 4 sandwiches are allocated. Okay, move on. Oh, this question. Yeah, this question is pretty simple. So your first, they give you this 3 times 5 times 7. And over here 3 to the power of 2 and times 5 to the power of 2. Over here 3 to the power of 3 times 5. So to find the HCF, right? So remember the definition, shared numbers and lowest power. Okay, it must be shared and then lowest power for that. So if you can see, 3 is shared, 5 is shared, 7 is not. So 3 and 5. Okay, 7 is not because the second number, no 7. There is no 7 in the third number also, right? So therefore you cannot pick 7. So for HCF, shared numbers and lowest power. So just choose the lowest power. So in this case, you have 1, 2, 3. So the lowest power is 1. And then for the 5, 1, 2, 1. For the power, so you choose 1. Therefore, 15 is the HCF. Now for LCM. LCM is what? LCM is, if you refer to this, once again, numbers that are present and highest power for the numbers that are present. So very simple, just whatever you see, just write it down once first. So you have 3, you have 5, you have 7, right? So it's 3 times 5 times 7. Okay, and then choose the highest power, right? So for LCM, you need to choose the highest power. Okay, so please remember it. Choose the highest power. Okay, so now choose the highest power. So among 1, 2, 3, the highest power for 3 is 3. So 1, 2, 1. So the highest power for 5 is 2. So there is only 1 7, and the highest power is 7. So what you end up with here is, so you have 3 to the power 27, and then you have 25, and then times 7. So what you do is you just punch your calculator. So you have 27 times 25, and then times 7. So you have what? You have 4725. Okay, pretty simple. Now find the smallest positive integer case such that this is a perfect cube. Okay, by the way, this is a very typical question. Okay, so you know that you have 2 to the power of 2, and then you have 3, and then you have 11, and you want it to be a perfect cube. So in order to be a perfect cube means you can cube root it. Okay, you can cube root it. So you can see that in order to cube root this, okay, you need to times what? Okay, in order to cube root this, okay, in order to cube root this whole thing, your k must contain what? Your k must have a 2, so that it becomes what? So it becomes 2 to the power of 3. And it also must have 2 3s, so that it becomes 3 to the power of 3. And then you only have one 11 here, right? So you need to give it two 11s, right? So you have 11 to the power of 3. So therefore this one can be keep root, right? So therefore your k is this. Okay, so and it must be positive. Okay, and it must be an integer, right? It must be an integer. So therefore 2 times 9 times 121, so it's 2178. Okay, so this one has to be the answer. Okay, next. Okay, over here it says factor 3, fill the missing number. So it's pretty simple, right? So let me give you another example of a factor 3. So let's start from 40. So you have 2 and then 20. Okay, over here you need to split 2 and 10. So over here 2 and 5, and you stop. Okay, next. So what you do here is you just need to punch your calculator. 2 times 455, and you get 910. That's what you start with. And after that, over here it should be 5, and then over here it should be 7. Okay, so that's it. It says express 910 in prime factorization form. So once again, prime factorization means 2 times 5 times 13 times 7. Okay, okay, okay. Oh, once again, I want to caution people, 1 is not a prime number. Okay, the first prime number starts with 2 and then 3 subsequently. Okay, next. Okay, this question, it says what? It says the table shows the average temperature for 4 different countries on this date. So Singapore is 30, and then Greenland is this, and then minus 14. So which country was the coldest? So coldest is definitely Greenland, right? You can see, right? Minus 22 degrees Celsius. Right. Next, what was the difference in temperature between Hong Kong and Norway? So for HK is 14, and then for Norway, so for Norway is what? Negative this. Okay. So in fact, a lot of students make these mistakes. What's the mistake? They go and add it. They go and add. I'm sorry. Let me clear my throat first. They go and add these two. Okay. So and then they end up with what? They end up with 4 degrees Celsius, which is wrong. Okay. To find difference, you cannot what? You cannot add. Okay. What you should do then? You should minus. Okay. So 14 minus. Yep, minus, and then you minus. This is Norway, and then this is Hong Kong. So 14 minus, you get plus, right? I don't need to write a unit here actually. It's not necessary. Okay. So I also don't need to write a unit here, because if I start with no unit, I should not end with unit. So this is 24. So right now you just write it down 24 Celsius. Okay, but when you write the answer, please remember the unit. Okay, next, what was the average temperature of the 4 countries? So the formula for average is what? The formula for average is total divided by number of items. So what you do, you just need to add all this up. So it's 30 plus minus 22 minus plus minus 10 plus 14, and then how many countries are there? 4 of them, right? Okay, so I will leave this to you. Just use your calculator, punch your calculator, and you should get the average temperature. Okay, very, very simple. Okay, last but not least, let's look at this question together. It says there are 3 lights on the table. Okay, and then light A blinks every 6 seconds. So every 6 seconds. Then light B blinks every 8 seconds. Okay, and then light C blinks every 9 seconds. And given that the 3 lights start to turn on at this 5:55 a.m. and determine the time when the 3 lights will light up together at the same time. Okay, here I want to be a bit strict here. I want to find the next light up moment. Okay, will next light up together. Okay, I don't want the second round, I don't want the third round, I want the first next light up moment. Okay, so I need to be a bit particular on this thing. Now I need to get the prime factorization of all of this first. Okay, and then like 6 is equal to 2 times 3, 8 is 2 to the power of 3, and then 9 is 3 to the power of 2. So in order to know the next light up moment, I need to find the HCF or LCM. Okay, let's find both first. So in this case, let's find the HCF first. Highest common factor, so it must be shared, right? Remember? So in this, HCF must be shared numbers and then choose the lowest power. Okay, so let's come back to this. So is 2 shared among these 3? No, 9 doesn't have the 2, so 2 is not shared, so I cannot put it down. Next, 3 is 3 shared among these 3 numbers? 3 is here, there is no 3 here, right? No 3 in the 8. So 3 is here, so 3 is also not shared, so definitely I cannot put down 3. So in this case, by the way, there is no HCF for this question. Okay, so what I need to do, I can only go on to find the LCM. So for LCM is numbers that are present. So I see a 2 here, I see a 3 here, so 2 and 3 are present, and that's all. Okay, and choose the highest power. So looks like between 1 and 3 for the power. So 3 is the power, I choose the highest power. So 1 and 2, I choose the highest power for 3. So this is the highest power for 3, which is 2. So therefore I get what? 2 to the power of 3 is 8, and then 3 to the power of 2 is 9, so LCM is 72. So by the way, this is in terms of seconds. So if it lights up at this 5 or 0, 5, 55, and then 0, 0, if it start to turn on at this moment, so I need to find out what is the next moment it lights up together, right? So I need to change this 72 seconds to 60 seconds to 12 seconds first. The reason is I need to convert it into 1 minute and then 12 seconds left, right? So therefore I need to add 1 minute to it, and then I need to add what? 12 seconds to the starting time. So I end up with what? 05, 56, and then 12. So this is the time the 3 lights will light up together next. Okay, so very good example here. There is no HCF for this question. Okay, and by the way, you don't need to find this HCF. Okay, you are supposed to find the LCM. Okay, next, a bottle of water is 330 milliliter, and then what? Yeah, Peter is going to pour this bottle of water into 7 cups. So basically you need to pour it into 7 cups. So basically you divide by 7, right? And then what do you have after this? Okay, you have, let me use a calculator and see what I have. So I have 330 divided by 7. Okay, I have 47. 1 over 7, right? Okay, let me write it nicely. Okay, because the 47 should be in the middle, should be written here. Okay, not lower, not higher. Okay, so therefore that means I can fill this into 47 bottles, and then what is left? Okay, a lot of students will think 1 over 7 is left, milliliter. Is it true? They think that, yeah, 47 bottles, and then 1 over 7 milliliter left. Is it true? The answer is no. Okay, so as you can see, if you do reverse engineering, meaning what? Meaning if you try to write 47 bottles, and then 1/7 milliliter left. You can actually try to see if you can get back the original 330 ml. So 47 bottles, okay. Okay, no. So the unit here is not bottles. Very good. So sometimes I believe if I make mistakes, students will make mistakes, definitely. So it's not about making mistakes here. It's about when you make mistakes, do you self-correct? Do you or can you self-correct? So in this case, I realize I can self-correct myself. So each cup will contain 47 milliliter. Okay, each cup will contain 47 milliliter. Yes. So therefore, 47 I times 7 cups. So what do I get? So 47 times 7, I get 329 milliliter. And then this 1/7 milliliter left. So you just add these two up and see if you can get back the answer. So what's the answer here? Let me find out what is 1/7. It's 0.142 something. So therefore it is 329.14 milliliter something, right? So you clearly see that. Clearly see what? Clearly see that this is not the original volume of the bottle of water you started with, right? So therefore you don't make these mistakes. Okay, don't make these mistakes. Okay, so the correct way to do this question is, let me go to the new slide. 330 and then what? 7 cups. Okay, so you have a bottle of water. Start with this, and then you fill it into 7 full cups. First, second, and then until the 7th cup, right? So you use this. You do it by 7, which is correct. Okay, and you get what? So just now I get 47 1/7. Yes. So I get 47 1/7 milliliter. Okay, so now what you do is you need to split this. Okay, how do you split this? Okay, the way you split is, you find out 7 times 47 is what? 329 milliliter, right? So compare this 329 milliliter to this 330. Okay, so what is left? In fact, 1 milliliter is left. Okay, so the answer is, you can fill what? You can fill 7 full cups of 47 milliliter each, and then you have 1 milliliter left. Okay, right? You can actually do you can actually work backward. Okay, 7 full cups of 47 milliliter each, so that means you do 4 times 47, and then you just add 1 and see if you get 330. The answer is yes, you can get 330. Okay, so that's about it. So I hope you guys enjoy my video, and yeah, so see you again. Bye bye.